the Zero Latency Enterprise is a way to integrate applications and data from across your business in real time. It provides the technology and the methodology to create a single view of your enterprise data. Now in this case, that data is about customer. We call the concept enterprise personalization. And what that means simply is a single view of your customer information across all channels. Now that part isn't unique, but in real time is. And that means from 2 years ago until 2 seconds ago, every interaction you've had with your customer at the call center, every click at the e-store, every point of sale transaction, every interaction, as well as all the state information you have about their demographics and where they live and what they prefer, all in real time in one place, so that you can use it to better personalize to the customer. The other point here is that we have one consistent set of rules and policies for the treatment of that customer. So whether they're coming into the e-store or through the call center or any channel that they want to talk to you through, you can have one consistent way of treating them rather than letting each channel kind of make up its own policies for the treatment of your very important customers. Now, in order to appreciate how this concept works, we'll need to follow one guest or one customer through all of their interactions with us. So I want you to meet Rhonda. Now Rhonda is 28 years old. She has one small child. She's been recently engaged. She holds none of our credit cards and she's not in our database. We know nothing about Rhonda. In effect, she's completely anonymous to us. And she's about to browse our website for the first time. Now since she's anonymous, when she browses the website, the first thing that's going to happen is we're going to make an offer to her. But it's not going to be a very intelligent offer. And if you look at the screen, you'll notice we offered 3 products, and this is the standard assortment of products. Now, in reality, to make that offer, we reached into the Zero Latency Enterprise architecture, and we looked at everything we knew about Rhonda, which was nothing at this point. So we made the default offer. But what we should be able to do is, as she begins to interact with us, to take the real-time information about Rhonda and to use that to better personalize to her. So Rhonda's going to start shopping for housewares because she's about to get married. She'll look at this rather modern-looking Movado clock. And as she looks at that, we'll log that information. And in fact, they sent the information from the e-store to the ZLE, and in return, we responded with an offer, which was these batteries. Still not a very intelligent offer, but an offer nonetheless from us. If we were to go and, for instance, look at lamps, and she wants to browse further, and she'd select maybe a very modern-looking reading floor lamp. At this point, she's done 2 browses of contemporary-styled items. Now, we know something about her preferences. So to help her with our website, we ought to be able, that when she goes back to the home page, we ought to be able to make a very specific offer. And what you see here now is a series of contemporary styled items. And as we begin to browse down through the items, we'll find that the contemporary items will always bubble to the top. Even if there are 4 pages of items we're showing, the ones that she would like the best are always going to be presented first. Now Rhonda doesn't know we're personalizing to him. She just thinks we're having a really good website for her. Okay? Now, to take this further, Rhonda's going to begin to interact with us, but she's actually going to come register with us in our bridal registry system. Now in this case, she's going to tell us who she is. And although we'll have no idea that she's actually been browsing our e-store, she's going to be known to us now in our gift registry system. Now the problem is gift registry is not integrated with any other system we have. It's its own standalone database and it has its own information about Rhonda. So as Rhonda begins to browse and go into our gift registry system, we're going to be able to actually insert her. And what I'll do here is add Rhonda to the Oracle Gift Registry database. And what you'll notice on the roadmap screen that you see is that as I add her, she'll not only be inserted into the gift registry system, but the ZLE will capture that change. It'll be propagated to our database. Now in addition, we're going to clean it up a little bit. We're going to fix her address. We're going to add the postal codes. We're going to actually geocode it with longitude and latitude information. And then we're going to actually reach out in real time over the internet and we're going to buy data from a service provider, in this case Axiom, and we're going to add demographic information. So you'll notice we now know Rhonda's income. So we've got a lot of information as well as a pointer back to gift registry with her unique identifier, the gift registry ID, that tells us where she exists. Now, to continue on with the personalization, we're going to need to add some history for Rhonda. So I'm going to insert some point of sale transactions. I'm going to insert some calls to our call center. We're going to bring a little bit of background in so that we can begin to do a little bit more personalization and do things to a little bit more complex level. So the next thing we might do is we might do an email campaign. And in this case, we use the Protagonist software from Recognition Systems. We query through our database and we find all the people who meet a certain criteria, people who actually browse department store related items before, who've made purchases that match certain criteria, have certain demographics. And we'll offer them a discount credit card at one of our department stores. Now, the offer will actually be sent out in the form of an email. And as that offer goes out, and we take a look at the email that we would send to her, we do one really interesting thing. And that is, we actually put in the offer a guest ID. When she links herself from this email to our site, to our website, we'll see that her guest ID will actually be passed to us. Now what this means is that her anonymous history, where we knew that she was browsing but only knew her by her cookie, will be joined immediately to all of her known history. And from the anonymous side, we'll know that she has a preference for contemporary styled items. But from her known history, we'll actually know something about her purchase patterns and something about her preferences as far as does she like expensive items or less expensive items. So now as I link into that e-store, what we'll find is that the same e-store will make an offer on the front page which includes some very contemporary styled items, but they're actually very expensive, very upscale items. So by combining both her known and her anonymous history in real time, we're able to personalize very effectively. Again, we've never said anything about, hello Rhonda, we haven't told her that we know who she is. She's just finding our website is presenting the things that she's really interested in first. Now, as we carry this further, Rhonda might decide once she's married to actually call into our call center and tell us that she has a new address. Now the challenge here is twofold. One, I want to be able to take that information about her address and let everyone else know that that event has occurred and push it out in real time. The other is the call center, in our case a ZLE 2000 system, has the ability to personalize to her if I just provide it with the right guidance. So by tightly integrating then the ZLE solution into the ZLE, ZLE is actually able to make very, very intelligent personalization to Rhonda in real time. So what will happen is, as I come into ZLE 2000, all this data is coming out of ZLE's database. As I select Rhonda, what we'll see is the top of the screen will actually come out of the ZLE database. The middle of the screen is detailed information that came from the ZLE. It's data that wouldn't have naturally been with ZLE. So we have details about her recent interactions, that she's had 2 calls to the call center, she's had $1,270 worth of purchases in the last 2 years, when her last interaction was, when her last session on the web was, and what the most recent offer was. And I actually can reach into the ZLE and see her line item detail of her purchases and every offer that we've ever made to her as an example. So this integration allows us to actually see the information about Rhonda that may not be resident within ZLE. But to go further than that, we want to be able to make offers to her. So to make an offer to her, ZLE actually can make a call to the ZLE and ask, what kind of a recommendation do you have about what I could offer Rhonda that she's interested in? So what we're going to do is we're going to change Rhonda's address here. And what we'll notice as we change her address and enter it, if you look at the roadmap, is that we'll actually add the new address to the ZLE database. It'll be automatically migrated to the ZLE, where we'll notice that Rhonda has already been registered in our gift registry. We'll then reach out to gift registry and give them the new ID for Rhonda. Now the other thing that's rather interesting about this event is that we're going to make an offer. And the offer in this case is fairly intelligent. The offer in this case is 25% off of all baby-related items at one of our super grocery stores. Now, to make that offer, let me help you understand the rule that we used. The rule is if the guest is greater than 10 miles and less than 20 miles from one of our super groceries, they've purchased baby-related items in the last 2 years from one of our stores, and we have not offered them anything in the past like this, then we should offer them 25% off the baby-related items at a super grocery. Now, how did we know where she lived? When she actually was added through the bridal registry system, the ZLE captured that information, and in addition to buying the demographics, we geocoded and determined her longitude, latitude of her address. By using that, we can calculate her distance. And in this case, she fit this rule, so we're going to offer her the 25% off discount. This gives you a feeling for the kind of complexity of the rules we can build and the type of data we can bring in to be able to build those rules and to be able to make these offers. Now, finally, we might take a different spin at this, and this is, how would we do something like fraud detection, or asset protection, as we might call it in a retailer? In this case, we want to determine what are the properties of a transaction that might be fraudulent with a credit card. And as we study the data, what we'll do is export data from the ZLE into a data mining system. In this case, we use SAS, one of our good partners, to understand the characteristics of a transaction that might be fraudulent. In this case, we learned that the characteristics of a fraudulent transaction would be that the credit card was reissued in the last 30 days. In this case, someone's probably called in, reported a stolen credit card, or a lost credit card, and then they'll go steal it out of your mailbox so they can go make purchases. So a recently reissued credit card, a lot of refunds in the last 24 hours, and a high ratio, for instance, of electronics purchases today versus your last 2 years of history. So with all these different attributes, we can actually build a fairly complex rule that will predict the fraud. And in this case, the rule is if the card's issued 30 days ago or less than 30 days, greater than one refund today at more than one store, the ratio of electronics purchases today versus the past 2 years is high, then we'll recommend that there's a high chance of fraud. So to see these rules in action, we're going to have Rhonda, or whoever stole her credit card, request a refund. And as I come into the refund system, I'm going to select out some items to do a refund on. We'll see that the line item detail for a certain purchase is here, and I'm going to refund this television. And at the bottom of the screen we see that it makes an offer to actually upsell me. She's done nothing wrong. She has nothing fraudulent in her history, so we decided to take the opportunity to offer her to join a local college program where we support our college and she can contribute part of her purchases to a local college. Now, to show you how this works, we'll actually go in and insert some point of sale history that's kind of suspicious. So now we're going to insert a few purchases and a few refunds. They're going to push Rhonda's credit card into what we would consider a medium probability of fraud. And now if I go back and request that same refund, it'll reach into the ZLE, it'll fire the rules engine, it'll look at everything it knows about Rhonda and say, this refund may be fraudulent. Maybe you should get a second guest ID from this guest. Now to push it even higher, we'll have Rhonda make, or whoever has her credit card, make a whole series of purchases that are just incredibly fraudulent. Now this should be very obvious, and it'll trip that high fraud rule that we talked about earlier. So if I go back to the refund system, request that refund a third time, now it says the refund may be fraudulent, security is being paged. Now two interesting things happened here. First, the rules engine was able to look at everything it understood about that transaction and to make that offer. And the other is that it actually pushed the message to a handheld device, an intelligent device in this case, one of our iPac Pocket PCs. And in this case, we're able then to go in and look at Rhonda's history. And we can see that the offer that's been made, specifically in this case, was that there might be a fraud. And if we look at that fraud offer, we'll see that it is determined that Rhonda's credit card has made a purchase that looks kind of suspicious. And it suggests to the store security agent that maybe he should go over and see who's using that credit card and see if it might be someone other than Rhonda. So now, to build a one-off of a demonstration like this is one thing, but to put it under load in a production environment is different. So to categorize how that works, we have a rack of flat panel displays here that show various aspects of the business. We see in real time the transactions that are occurring, the level of point of sale, the total dollars. We see all kinds of information about the business being pumped out of the zero latency enterprise architecture in real time. But in the center you see that we've actually put it under load. We're running about 128 refunds per second and about 380 point-of-sale transactions per second. Now this is equivalent to about double the largest retail chain in America's point-of-sale load and refund load concurrently. Now in addition to that, we're running about 200 e-store interactions per second. Those could be browses or purchases. And at the same time, against the same system, we're running these call center transactions at about 150 per second, which would approximate about a 2,000 or 3,000 seat call center. So to run all these things concurrently in the system, to be able to support that centralized concept and to be able to put information out to all of these touch points that have a complete view and a centralized view of the guest's information is absolutely key to making the ZLE work. You've just seen enterprise personalization at work. This has been a single view of the customer across all channels and across all applications. In real time, we used information from seconds ago, minutes ago, hours ago, weeks ago, all the way back to the beginning of our relationship with this customer to be able to personalize to them and doing a very effective job. We have one consistent set of rules and policies for the treatment of this customer across all channels. Now a lot of people are talking about real-time CRM, but Compaq's delivering it now.